What up, athletes? Whoop, whoop. All right, so here's our warm-up. Go ahead, take a look at it. Remember to follow the directions carefully. In the figure, parallel lines M and N are cut by transversals S and T. So we know M and N are parallel. We do not know that about S and T. Write down true or false for each of these. In the second one, suppose lines M and N are parallel and that lines S and T are parallel. Then write true or false. Ready, set, go. Pause me. And we're back. Is angle 6 congruent to angle 1? Hold on. Excuse me. Whoa. Angle 6. Is that congruent to angle 1? Well, angle 6 is congruent to angle 3. And angle 3 is supplementary to angle 1, so no, that's false. That means angle 6 would be supplementary to angle 1, but not congruent to it. All right. Angle 12 congruent to angle 13. Let's see. Is angle 12, where's it even at, congruent to angle 13? Yeah, those are alternate interior. Alternate interior angles are congruent. So yeah, true. Angle 4 and angle 11 are supplementary. Well, let me erase all this other stuff we have here. It's saying are angle 4 and angle 11 supplementary. Well, here's the deal. I have no idea. And the reason I have no idea is because of right here. They're cut by transversals S and T. If S and T were parallel, then yes, they would be supplementary. But we don't know that. Because I don't know that, I have no idea. So that I'm going to have to answer false. All right? Okay. Let's go ahead. Now we're going to assume that they're all supplementary. Or all parallel, excuse me. M and N are parallel, and then S is parallel to T. Perfect. Is angle 6 congruent to angle 15? Well, where's 6? 6 is right here. And yeah, those would actually be, if I were to flip this over like this, those would be another form of alternate interior angles because they're inside of the parallel lines S and T. So yes, true, those are parallel. Angle 4 is, or congruent. Angle 4 is congruent to angle 13. I don't know. Let's see, angle 4 is opposite of angle 13, and yeah, angle 4 is congruent to angle 13, true. Last but not least, angle 4 and angle 11 are supplementary, true. Because again, now that I know they're parallel, angle 4 and angle 12 would be corresponding. Angle 12 is supplementary to angle 11, which means angle 4 is supplementary to angle 11. So boom, yes, that is true. And here we go. Right. Let's start today's lesson. It's going to be a bit of writing, but let me explain how to do it first so you don't have to write quite so much. And let's talk about the concept of parallelograms. So today we're really hitting on parallelograms. And as that loads up, whoop, did not mean to do that quite so much. A simple mechanism is a structure composed of fixed parts that slide or are hinged together. These mechanisms are used to create machines that can transfer or amplify force. When the opposite rods of a simple mechanism are the same length, the mechanisms use a parallelogram in which you can change the angles. This allows the pairs of opposite rods to remain parallel as the mechanism moves. Lifting machinery often uses multiple parallelisms to create movement in more than one direction. So, ultimately, I want to move this dude up. I want to move him up. But to do it, I'm going to have to move one mechanism up this way that's pointed to the left, and then that's going to move another mechanism up the same direction that's pointed to the right, which is going to we're just transferring force. So watch what happens here. We're using this parallelogram to move this arm up, which allowed us to change our angle or direction to move this arm up, which is another parallelogram, which is changing it once again. So we can, in a very efficient manner, lift this bucket up to a pretty great height the more we extend it. And yet the beauty of this is, think about it. So this man can lift up this high, but if we didn't have parallelograms, then the arm, instead of being folded kind of in on itself like this, it'd have to be sticking straight out this direction, which would be a really odd car to have, right, to port around. So it allows us to be more efficient in our usage of space and transfer of force. All right, awesome. Let's go ahead and talk about parallelograms. There's a lot of properties that come with parallelograms. So here's what I want you to do. I'm going to kind of skip this overall drawing right here. So a parallelogram, though, let's just vocabulary-wise, it's a quadrilateral with both pairs of opposite sides parallel. Write this down, pause it as you need to, and then let's roll. Here's where we get into the good stuff. Properties of parallelograms. So a parallelogram is a quadrilateral that both pairs of opposite sides are parallel. To name a parallelogram, use the symbol boom. So in other words, instead of writing the word parallelogram a whole bunch of times, just draw this symbol, okay? Much better than me with a mouse, though, please. And what do we know? In parallelogram ABCD, BC is parallel to AD, right? So BC is parallel to AD, and AB is parallel to DC by definition. So let's go down here. Theorem 7.3. Now, for the rest of these theorems, I want you to draw one parallelogram. And then we're just going to label it differently and write theorems beside it. So draw a pretty decent-sized parallelogram. And the first thing tells us this. And I'm just going to use the abbreviation. Please just write down the abbreviation and the example for each theorem. So theorem 7.3. And you can just title these properties of parallelograms. They all are properties of parallelograms. Theorem 7.3 says this. If a quadrilateral is a parallelogram, its opposite sides are congruent. So which means JK is congruent to ML, right? JK is congruent to ML, and JM is congruent to KL. That's all you need to write down. Just these two things right here under 7.3. Pause if you need to. Let's move on. Using the same parallelogram. Now we're just going to label the angles. And our theorem 7.4 says if a quadrilateral is a parallelogram, its opposite angles are congruent. In other words, angle J is congruent to angle L, and angle M is congruent to angle K. Label this on the same parallelogram, please. Save yourself some drawing. If you don't want to, that's fine. Okay, pause if you need to. We're moving on. 7.5 then adds a little piece to that puzzle. Not only, so this told us J and L are congruent, but now I can say this. This theorem 7.5, if a quadrilateral is a parallelogram, its consecutive angles are supplementary. In other words, these are called consecutive angles right here. So J and K are consecutive angles. J and M are consecutive angles. See how that works? But here's what else I know. I know that X is supplementary with Y. So angle J is supplementary to angle K, and angle M is supplementary to angle L. Or in this case, if JKLM is a parallelogram, then X degrees plus Y degrees equals 180 degrees. That's all the same. Okay? That's powerful. Powerful to know that. And last but not least, theorem 7.6 just says this. If a parallelogram has one right angle, then all the angles are right angles, which means angle J, K, L, and M are all 90 degrees or right angles. Okay? Has to be. Once one, and we know that because if this is 90, it's our last theorem that really proves this. If this is 90, I know that these two are supplementary, which means they add up to 180. 90 plus 90 is 180. I know it's supplementary to L. That means 90 plus 90. See how it works? It kind of goes this way around. All right. Boom. So take these theorems, write them down. Again, you can write all this on just one parallelogram. Maybe draw a second one for this one since it's kind of a special case for basically you're making a rectangle or a square, right? All right. So now we're going to use these properties to solve some problems that are going to help you in your homework, which, by the way, most of your homework, no matter how complicated it looks, pretty simple if you just pay attention to this. Okay, so let's fill in what we know. It says find each measure. So we have a parallelogram right here. Okay, PQRS. All right. What is the measure of angle R? Well, if the measure of angle Q is 59, I know that Q and R are supplementary, so what's 180 minus 59? What's that you say? And that's a 9, yes, yes, yes. 121, yeah. So that's going to be 121. Boom. And now we want to know the length of RS. Well, QP is congruent to RS, so if QP is 3.9, then RS is also 3.9. That's it. Write down. Let's move. I'm drinking coffee while it's happening. Drag the reasons to complete the proof. Now we're going to do an actual little mini proof. Don't worry, it's not too hard. Oop, wrong button. Okay. Here's what I know. I have two parallelograms, HJKP and PKLM. And I do know they share a side, PK, so that's going to be important. Because we're told, let's write down what we know from our theorems. We know that PK and HJ are this. I hate it when that happens. We know that PK and HJ are congruent. I also know that PK and LM are congruent. So basically that tells me that HJ is congruent to ML, which is what we need to prove. But let's go about that the right way. Just says parallel, basically we're given parallelogram HJKP and parallelogram PKLM. What is that? That is a given. Then I know that HJ equals PK and PK is congruent to ML. That's because opposite sides of parallelograms are congruent. And then I'm going to cut out the middleman, right? I'm going to cut out that PK and just say HJ is congruent to ML. Why is that? That's because of the transitive property. Transitive property says, hey, if I got A equal to B and B equal to C, then cut out B, A is equal to C. I can translate that. And if we check it, awesome. But I better not forget to reset this resource, as I forget that all the time. Oh, I should probably say write that down if you need it. Well, definitely write this down. You want to make sure, no, we're just going to do little mild proofs here and there just to get your brain working in the proof way. But now I got to reset it. All right, here's a decent problem right here. Looks harder than it is. Let's use what we know about parallelograms. Find the values of x, y, and z in parallelogram QRST. I'm going to zoom in a little bit to this. And let's move myself out of the way. Now I'm moving myself up. And what are we? I'm not overwriting anything, am I? Nope, just making sure. So, what do we have right here? Let's start with x. X is over here on side QT, and then I know that QT is congruent to RS, right? Because opposite sides are congruent. So what can I say right away? I can say, hey, (5x) equals 27. Divide both sides by 5. And what do I get? X equals 5.4, I think it is. So we got our 5.4. Yeah, because it'd be 5 2/5, and that's 0.4. All right, how about our y? Well, something you need to know, and you should write this down. In fact, I'm going to scroll down. Let me delete all that. Scroll down. Study tip. Write this down. Congruent triangles. A parallelogram with two diagonals divides the figure into two pairs of congruent triangles. Pause it. Write it down because I'm going to move up here right now. When we made the diagonals. We separated this into two congruent triangles, pairs. We have one pair right here of TPS and QPR. And then we had another set of a congruent triangle, TPQ, and RPS. And here's what I know. TP is congruent to RP. That's true. I also know that QR is congruent to ST. Now that really helps me because to clear some things up here. So we see this side right here, TP is equal to RP. I was thinking for a second that these were the long side, but I wasn't. Anyway, so because I know that RP is congruent to TP, now I can say y plus 4 is equal to 2y plus 5. So I'll have y plus 4 equals 2y minus 5. Let's subtract y over, subtract y over. Boom, what do I get? That's gone. 4 equals y minus 5. Add 5 to both sides. And I get 9 equals y. So we have x is 5.4, y is 9, and last is going to be z, okay? So I'm going to erase this right down if you need it, and here we go. Ooh. Okay, so here's what I know now. If these triangles are congruent, then I know that 3z is congruent to 33, right? And those are alternate interior angles. So there we go. That works in a number of levels. So because of that, I can say, all right, 3z equals 33. Divide both sides by 3. And I get that z equals 11. Boom. So we should have 5.4, 9, and 11. Right, I'm going to delete this. 5.4, 9, and 11. Check it. Yeah, we got it. All right, let's go to our next problem. This one looks so much more complicated than it is. First time I saw it, I was like, whoa, whoa, hold on a minute. And then I realized, oh, yeah. So, although two diagonals, right? That diagonal and this diagonal would separate it into two pairs of congruent angles. Guess what? One diagonal just cuts it into two congruent triangles as well. So here's what I know. Check it out. I have a triangle. Let me get some drawing tools up here. I have the upper triangle and my lower triangle, and they're congruent. And it's really easy to find the area of a triangle. What this question is asking us to do is it says Marlene is making parallelogram shaped earrings to wear during her presentation in her geometry class. Find the perimeter and area of one of Marlene's earrings round to the nearest tenth. Okay? So first things first, I'm actually going to start with the area. The area is the easiest. Because if I look at this triangle, what is the formula for area of a triangle? So area of a triangle equals 1/2 base times height. And if I look at this triangle, just this upper triangle right here, so let me go ahead and let's mark that out. Just this upper triangle. Then let's look at that. That base is 1, 2, 3, 4, 5, 6. So that's going to be 1/2 times my base of 6 times my height. Well, my height is right here. 1, 2, 3, 4. A 4. And then how many of these triangles do I have? Well, I have 2, so I'm going to multiply that times 2, which is really great because when I multiply it times 2, guess what? That 1/2 cancels out, and I'm left with 6 times 4 is 24. So we know the area is 24. Now, write that down. The challenging one, and it's not really challenging, we just got to use the distance formula, but we've done distance formula, is for the perimeter. So, for the perimeter, I'm going to find out my distance here and multiply it times 2 because I have 2 of these, right? And then I'm going to find my longer distance. Once I do, I'll multiply it times 2 because I have 2 of them. So add those all together, and I get the perimeter. So we're going to have to do the distance formula. So let's find out what our points are. First of all, I'm going to use 0, 0 because 0 is nice. I'm going to use that to find both lengths because 0 is nice. My second point I'm going to use is right here, which is the point, what, 1, 2, 3, 4, 1, 2, 3, 4, 4, 4. And my last point I'm going to use is right here, which is 1, 2, 1, 2, 3, 4. So it's going to be 2, negative 4, because it's going down 4. All right. Now we're going to use this in our distance formula. Our distance formula, remember, to find the distance between 2 points is the square root of, in this case, looking at these 2 points, 2 minus 0 squared plus negative 4 minus 0 squared. And 2 minus 0 is 2. Negative 4 minus 0 is just negative 4. 2 squared is going to be, so that's going to be the square root of 4 plus, and then negative 4 squared is positive 16. 16, which equals the square root of 20, which I am going to round to the nearest tenth, and that comes out to approximately 4.5. And remember, I have 2 of these lengths, so that's the length, this red length right here. So I'm going to have 4.5 times 2 equals 9. We'll leave that right up there. Okay, make sure you write down, that's just using the distance formula. I'm going to erase that now, so pause if you need to. Do distance formula again. And this time, do it for square root of, just get these written out, squared plus squared. All right, I'm going to do the difference in my x value, which is negative 4 minus, or positive 4 minus 0. 4 minus 0. And again, my y minus my y is going to be 4 minus 0 again. So just 4 squared and plus 4 squared, which is going to be 16 plus 16, which equals square root of 32. And what's the square root of 32? I don't know. Let's find out. Set function, square root of 32. It's approximately 5.7. And let's put it over here, 5.7. 5.7 times, sorry those interruptions. If I hear a beep or an announcement, I pause the video. But anyway, 5.7 times 2 is just 11.4. And when I add those together, I get the total perimeter of 20.4 centimeters. Boom. It's a good math problem. All right. That's it for today. You're released to your homework. Peace out.